Okay, now this is this house in Riverside that I did the 3D model for, and it's just a single story. But I had some questions about the existing drawings have caissons along the western wall of this house. And I wanted to get Brian's opinion of why that might have been necessary. Now let me switch over. Okay, here's the original drawing. Are you able to see this PDF?
Yes, I can.
Okay, you see these circles? You see
Uh-huh.
these round circles that are shown along this footing of this wall? And then if we zoom in here a little bit, we might be able to read this. It says 18-inch piles at 6-inch on center max. They run a caisson all the way along here, every 6 feet along this wall. And I'm wondering if perhaps it has to do with the fact that on this side of the building, they got a 4-foot overhang. On the west side, which is kind of a strange thing, the original drawings show, let's go down, let me do this. You see this on this side of the building, that's a 4-foot overhang. On the other side, it's only a 2-foot overhang, but on this side, and I think it's because it's the western wall. I think this is the western wall of the building. You see how long that overhang is? That's 4 feet and 4 feet, 4 feet, 4 feet. That whole wall is, and I think it has something to do with the afternoon sun. Maybe they wanted that extra shade. I don't know.
Oh, the overhang is for the sun, but the overhang has nothing to do with the caissons.
Okay, that's my question. So you think you think there's something along this line in the original soils test that might have prompted the addition of those caissons to this western wall?
Right. Is this a totally flat site?
Not totally flat, but not hillside,
But
not
what
heavy
happens going to
hillside.
the west of this house? Does it go downhill?
I don't have the topography of it. I don't have the survey, the topographical survey of it, but you never know. That's a good question. That's something to find out.
Yeah, no, my guess is they had to put structural fill underneath the west side of the house. So they use the caissons to get down to native soil for bearing.
Okay. All right. So probably what's going to happen is any kind of footing enhancement that happens to 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 deal with whatever they hope to accomplish with this project, it's going to have to take that into consideration.
It will, and probably the best thing would be to get a soils engineer to test the soil now and
Right.
give us values for bearing and skin friction and tip bearing for the caissons.
All right. Can you
And so there
recommend
may not
someone to
need
do
to
that?
be any foundation changes.
Okay. All right. Well, do you can you recommend someone that would help out with that?
In California, not really. You really need somebody who's really local to the area,
Uh, okay.
because they have to physically go out there and run tests and that sort of thing. So you want somebody who can just drive over there in 15 minutes.
Yeah, okay. Otherwise it costs you too
Right.
much. Okay. But I want your opinion also on this platform that we're trying to develop. All right.
Okay, and Brian, I was taking a look at the Wright Engineers website. I was just wondering, uh, let's see, what state do you operate out of?
We're licensed in all 50 states. We have offices in Irvine, California, Chandler, Arizona, Salt Lake City or somewhere near Salt Lake City in Utah, and Las Vegas, Nevada. Las Vegas, Nevada is our home office.
Okay. Okay. And it seems like you've been doing this for a while. How long have you been doing it for?
Me personally,
Mm-hmm.
30 years.
Okay. Yeah.
Wright's been in business for 23, 22.
Okay. So you joined on board later.
Yeah, I did other things first. I did major industrial engineering, structural engineering, wastewater treatment plants, lift stations, bridges, that sort of thing.
Okay.
Then I went on my own with a partner and we just did residential. And then I joined up with Wright about 9 years ago to do mainly structural insulated panel design.
Okay.
You do a lot of the SIP stuff then. Yeah, I was gonna ask you about that.
That's all I do anymore.
Yeah,
And
all right.
it's getting more and more popular because wood prices have doubled and SIP prices have only gone up about 10%.
Now, what is SIP? Is that are those like almost like pieces that you kind of like plug in together, or?
Yeah, they're
Insulated panels.
the typical SIP today consists of an OSB skin on either side of an EPS, an expanded polystyrene core. So you have oriented strand board that's pressure laminated to an expanded polystyrene core. And the core is a 2x dimension. So the core thickness is 3.5, 5.5, 7.25, 9.25, 11.25 inches. And so that's your actual panel. And the panel is going to be up to 8 by 24 feet in size. And then there's splines that are like the mini SIP that go between them and connect them together. So it's like it's a panelized wall system, but there's no studs, there's no energy transfer through the wall. So environmentally, they are superior to almost anything out there. Structurally, they're stronger than 2x. Faster to go up. They go up at about a third of the time or a quarter of the time.
Okay, I was going to ask. So they're easier to assemble then.
Yeah, and it's harder to make a mistake with them because they come fabricated from the manufacturer. So 2x construction, it's easy to make a mistake. You just do something wrong. You put two 2x4s in instead of two 2x6s or something like that. With SIPs, you can't really make a mistake.
Yeah, and these
Okay.
days you have to almost idiot-proof things.
So, well, right now they're building a car barn out at a racetrack south of here, a private racetrack. It's 64 feet by 58 feet, 24 feet in the air, 24-foot high walls. 2 guys are doing it, and it's taken them, this is their second week. Well, no, this is the start of their third week, and they're just finishing up the roof.
Well, I tell you what, we got a lot of fancy dormers that'll fit on top of your SIPS roofs. Check out our website. Check out our videos.
Yeah, I mean, if you have a SIP roof and then you have a decorative dormer, you can just
Yeah,
attach
fits
it
right
right
on
on top. So
Yep.
that works just fine. That's one of the concerns, or I guess issues with SIPs, is that if you have a really cut up roof, a lot of valleys, a lot of hips, a lot of dormers that are real dormers, things like that,
Yeah.
it makes it harder for the SIP because the SIP needs to bear on something. So your subframing becomes quite elaborate. But if you have like this house here that we're looking at, that's perfect for SIPs if they were building that house from the ground up.
But you can see how these STL files help people visualize what they have to work with.
Right.
And I sent you the STL for this house. And so you can see how we allow people to look through it, and makes everything easier for them.
Yeah, we do all of our designs in 3D Revit, which gives them a good look.
Yeah. All right. Well, thank you very much for your time. I'm glad to have had you on board.
I'm glad to do it. Thanks.
All right. Thanks, Brian. And hey, if you don't mind, would it be okay if I linked your website down in the video description?
Sure,
Is that what you'd like to use, the rightengineers.com?
yes.
Okay. All right. Thank you, Brian. Nice to meet you.
Nice to meet you.
Okay, we'll see you guys.
Okay, thanks, Glenn.